Hi, I'm Rasel Parvej. I'm an assistant professor and soil fertility specialist for LSU Ag Center. Today I'll talk about reevaluation of fertilizer recommendations for soybean production in Louisiana. Under this topic, I'll cover two things. First, phosphorus and potassium fertility at different soil depth. And second, reevaluation of fall versus spring phosphorus and potassium application timing. Let's start with the first one. Soil test-based fertilizer recommendations are very common and effective method across United States. Most of the land grant university develop fertilizer recommendations based on topsoil nutrient concentration that is usually 0 to 6 inch depth. This topsoil-based fertilizer recommendation is very effective, especially in fine texture soil, that is clay soil, where most of the nutrients are stratified on the topsoil. However, for coarse texture soil, that is sandy to silt loam soil, we often find no to low nutrient specific stratification in the uppermost depth. Here is an example. This photograph represents nutrient concentration across different soil depth. If you see potassium concentration, it is increasing as you go down to the soil profile. This is one of the main reasons that often gives us false positive yield response to potassium fertilization. That is, you sometimes don't see yield response to potassium fertilization even though your topsoil is deficient in potassium. This is because you may have a deficient potassium concentration in the topsoil, but you may have lots of potassium down to the soil profile that soybean roots can get the potassium and fulfill its requirement. So based on these findings, we hypothesize that both topsoil as well as subsoil potassium availabilities needs to be considered to develop a better fertilizer recommendation. So the objectives of our study was to evaluate soybean yield response to soil test phosphorus and potassium concentration at 3 different soil depths. For these objectives, we conducted 14 site years research in 2020. 10 sites were actually at research station and 4 sites were actually on the producer field. We have 5 different rates of phosphorus and potassium fertilizer that we applied at or before planting, and we took soil samples before we put out any fertilizer, and we took soil samples from 0 to 6 inch depth and 0 to 12 inch depth, and we did not take soil sample from 0 to 18 inch depth due to labor shortage. We also collected tissue sample and crop reflectance data at the R2 stage, that is blooming, and we collected soybean yield at maturity. Due to the time limitation, I will talk about only soybean yield. This graph represents soybean yield across soil test phosphorus concentration at 0 to 6 inch depth. Here is the x-axis, soil test phosphorus concentration in ppm, y-axis is soybean relative yield in percentage. So there is 14 dots, and each dot represents one side. So the red dots represent unresponsive side, where we put fertilizer like a phosphorus fertilizer, but did not see any yield response. The green and blue dot represents responsive side, where we put fertilizer and see yield benefit. If we develop a critical concentration that represents 90 to 95% relative yield, that critical concentration would be 21 to 30 ppm, which is very similar to our current critical concentration that ranges from 21 to 35 ppm. So on the left side of the critical concentration, we have a deficient zone. On the right side of the critical concentration, we have sufficient zone. So on the deficient zone, we had 5 total sites, and out of 5 sites, 3 sites were responsive. So our critical concentration actually 60% accurate in identifying potassium or phosphorus deficient site. So if you have a deficient phosphorus concentration, you may lose up to 20% yield. So this graph represents the similar yield response, but at 0 to 12 inch depth. And if you develop a critical concentration that corresponds to 90 to 95% relative yield, that would shift little bit, and it ranges from 15 to 23 ppm phosphorus. And on the deficient zone, we see our accuracy is going little down, that is 50% in identifying phosphorus deficient site. So we are not improving our critical concentration or predictability by taking deeper soil sample. This is because phosphorus is highly immobile in soil, so we may need to take a shallower sample like 0 to 14 inch to get a better predictability or increase the accuracy. This graph represents soybean yield across soil test potassium concentration. Here is the x-axis potassium concentration in ppm, y-axis is the soybean relative yield. Again, the red dot represents unresponsive site and green dot represents a responsive site where you put fertilizer and see a yield response to potassium. If you develop a critical concentration, that would be very narrow because it represents from 90 to 95% relative yield, and it ranges from 100 to 120 ppm. But if you look at the current critical concentration, it varies with soil type and the range is very wide. But we don't see that trend in our research. So on the deficient zone, we had total 7 sites, and all sites are responsive to potassium fertilization. That is our critical concentration. Even it is narrow, but it was 100% accurate in identifying potassium deficient site. And if you are on the deficient site, if you don't put any fertilizer, you may lose up to 35% yield. So this graph represents the similar yield response, but for 0 to 12 inch depth. And if you develop a critical concentration, we did not see any shifting at a similar response. What the critical concentration at 0 to 12 inch depth was 100% accurate in identifying potassium deficient site. So let's recap the key points. Our preliminary data suggests that critical soil test phosphorus concentration at 0 to 6 inch depth was 60% accurate in identifying potassium deficient site. However, critical soil test potassium concentration at both depth were 100% accurate in identifying potassium deficient site. The current LSU Ag Center critical soil phosphorus concentration at 0 to 6 inch depth is still valid across all soil types. However, critical soil potassium concentration at 0 to 6 inch depth was accurate only for silt loam soil, but not very accurate for clay soil. And we did not see any trend in changing critical soil test PA, phosphorus and potassium concentration between 0 to 6 and 0 to 12 inch depth. This research will be continued this year and next year. Let's move on to fall versus spring phosphorus and potassium fertilization trial. The main reason for this research was most of our producers still believe that they have to put both phosphorus and potassium fertilizer, that is TSP and potash, in fall because it takes longer time. It's a rocky materials, takes longer time to dissolve and become available for plant uptake. And this is not true. You can put easily this both fertilizer in spring, and if you have a rainfall, it will dissolve within a week actually and become available for plant uptake. Let's look at the results. We had two tests or two trials for this study. One at the Macon Ridge Research Station in Winsboro, and other one is the Northeast Research Station at St. Joe. We had 3 treatments, one like a check with no P and K, fall recommended amount of P and K, and spring recommended amount of P and K, and y-axis is the soybean yield. We see a yield response if you put fertilizer because it was a deficient site. Both sites are deficient, but we did not see any yield difference, statistically yield difference between fall application and spring application at both locations. However, we did see there is a 3 bushels yield benefit if you fertilized in spring rather than in fall. And this is because you have lots of time to lose some nutrient if you apply in the fall and it goes through the winter and there is lots of rainfall. If you have a sandy or coarse texture soil with low CEC, you may lose nutrient either through leaching or runoff. So our preliminary data suggests that also it was not significant. There is a trend of getting benefit from spring P and K application compared to fall application, especially for silt loam soils. With that, I like to acknowledge Louisiana Soybean and Grain Research and Promotion Board for funding this research. If you have any questions, please feel free to contact me. Here is my contact information. And thank you.